Hello guys, welcome back to the third part of the LFD Steel Bridge low rating using LARS. Now, in the last part, we needed to model the concrete slab of the composite section. So let's go right now and do that. Alright, go to description and go down to the member shape description. And concrete slab. Now, here, first part will be the full slab, the second part will be the effective slab, and the third part will be the fillet, or as we call it in bridge engineering, the haunch. Now, let's find out our full slab dimensions, the width and the thickness. So our width will be the center to center spacing, and it will be 124 inches, and our thickness will be 7 inches. So let's go and do that now. Width 124 inches and the thickness 7 inches. Now, our effective slab will be 84 inches wide and still 7 inches of effective thickness. 84 and 7. Now for the haunch, you will need to do some calculations, right? So the first part of the haunch will be 10 inches here, minus the slab thickness, minus the top flange thickness. That will give you 2.375 inches of haunch. So the width of the fillet, we're gonna say is 12 inches because we don't have any information, so we're gonna assume it's the width of the top flange, and 2.375. As you can see, we have two different plate thicknesses on the top flange, so we need to calculate two different haunch thicknesses. If you have more information on your bridge and the plans, you can refine this calculations, but right now that's all information that we have. So this will be just for the first 20 feet of our bridge. Now, the next part will be the DC. And the DC, it's the distance from the center line of your effective slab to the top of the top flange. Here you can see DC, center line of effective slab to top of the top flange. This illustration will also tell you what is the DS, which is the distance from the top of your effective slab to the center line of your reinforcement steel on the slab. In this case, we're not going to be modeling the steel on the slab, so we're going to leave blank the DS. But if you need it to refine your model, then here you have it. So for our first section of slab, the DC will be half the slab plus the haunch, be 5.875 inches. So 5.875 inches. Now, steel area, we're not gonna do it, as we said before. So I'm gonna go from the left reference, pick my left support, and then the distance, that will be 20 feet. Add, and there you go. That's your first section. Now, if you repeat the same process for the second section, you will find that your haunch, it's 2.125 inches thick, and then your DC is 5.625 inches. So let's put in this into to LARS. So all the information stays the same. The only difference will be the fillet and the DC. Like I said before, I like using the last three options, but you can use any of these options if you feel comfortable, but I prefer using the last three. So the haunch will be 2.125 inches thick, and the DC will be 5.625. Now I will use the left hand reference. I will reference from the slab that I already created, and I will reference from the right of it, and it's going to be for a distance of 40 feet. There you go. Now the next section should be equal to this first section, so I can just say, well, I want to reference from the left. Select my left reference, which is the middle part. From where? From the left, from the center, or from the right? Well, from the right. And it's going to be for a length of 20 feet. And there you go. Now the other way that I like to do it is both end reference, and I will reference my left side, which is the center slab, from the right of the center slab, which is right here, and then my right end reference will be the support. Boom. That's another way of doing it. Now everything here is done, and we can close and go back to the next section. Save it. Now our next step will be to input the dead load description. Alright, so for the dead load, you have to remember that the software already calculates the weight of the slab and the dead weight of the slab and the dead weight of the beam, right? So you only need to calculate the superimposed dead load from any diaphragms that you had, the barrier, and the wearing surface. So we already went through those numbers, and the superimposed dead load will be 0.523 kip per foot per girder. So we go to LARS, and remember that we select continuous, constant, stage 1. This distributor load, it's on pounds per foot, and the one that we calculated, it's on kips per foot. So make sure you're aware that this is in pounds per foot. 23. Again, the same thing. I like to use the last three options. In this case, I'm going to use the last one. Reference my left support and my right support, and add. And now I have a continuous distributor load. Well, that's all we have for now. I'll see you on the next video. But before you leave, make sure you save it. and safe. All right, see you in the next video, guys.